Today's lesson is about multiplying and dividing fractions. We're going to learn how to multiply and divide fractions using some new rules that are different from the ones used with adding and subtracting. Let's get started. Before we begin actually solving problems, there's a couple of key terms that you need to be aware of. Both of these are going to apply more to the dividing problems than multiplying, but they're important to know. A reciprocal is basically when you take a fraction and you flip it upside down. Those two fractions that you have, so for example 2/3 and 3/2, are reciprocals. Using reciprocals, there's a mathematical property that says when you multiply them together, the answer will always be 1. That's important because that rule allows us to change division problems into multiplication problems and then solve them using multiplication rules. So again, reciprocals are when you flip a fraction, and the multiplicative inverse property says that when you multiply those two fractions together, you get the answer of 1. So let's start with multiplying. Here's the most important rule. This is going to save you time. It's going to save you work. It's going to make things easier to do if you remember this one rule. When you multiply fractions or when you divide fractions, you do not need to find a common denominator. Adding and subtracting were problems where you had to. You couldn't solve problems without it. But here you don't need to. If you choose to make a common denominator, it's not going to make your answer wrong as long as you solve correctly. It just makes more work for yourselves when you do it that way. So you do not need to find a common denominator. Another rule that will make multiplying fractions easier is that you are allowed to simplify the fractions in the problem before you even start multiplying. And not only can you simplify a fraction going up and down with a numerator and denominator vertically, you can also simplify diagonally. So as long as you're taking one numerator and one denominator in a problem, you're allowed to simplify it like you would any fraction. So you're going to see some examples of that in the video today. So here's example 1. Problem is 2/3 times 5/7. So the first thing I want to look for is, can I simplify either fraction? 2/3 is already in simplest form. 5/7 is already in simplest form. I'm also allowed to look diagonally. Can I simplify 2 and 7? Well, the answer here is no. What about 3 and 5? The answer again is no. So after you've checked all of that, you just need to multiply your problem using 2 times 5 and 3 times 7. So sideways is the way you multiply. So 2 times 5 is 10. 3 times 7 is 21. And that's your answer. When you are finished, though, you always want to check to make sure if the answer can be simplified. So here, 10 and 21 do not share a common factor. It cannot be simplified. So that is your final answer, 10 over 21. So 2/3 times 5/7 is 10/21. Okay? Let's try example number 2. In this example, we want to look up and down first. So 5/9 and 3/10 and see if either of those fractions can be simplified. Here, neither one can. But if you look diagonally with 5 and 10 or 3 and 9, both of those sets of numbers can be simplified. And since one is a numerator and the other is a denominator for each pair, that means I'm allowed to simplify them. So we can simplify vertically, like I said, or diagonally. The only way you cannot simplify is horizontally. You cannot look at 9 and 10 or 5 and 3 to try to simplify. It has to be one numerator and one denominator. So here, we're going to take the 5 and the 10 and we're going to divide by 5. So if I cross those out, if I do 5 divided by 5 and 10 divided by 5, I get answers here. So 10 divided by 5 is 2. 5 divided by 5 is 1. And now I'm simplifying my problem before I start. It's helpful to do this because it's going to make your multiplying easier when you're done. So you're going to have smaller numbers to multiply. So instead of multiplying 9 times 10, we're going to multiply something times 2 after we finish simplifying. And since they're smaller numbers, it should be easier to multiply. Okay? Look at the other set of numbers, 9 and 3. What can they both be divided by? Well, they can both be divided by 3. So if we do 9 divided by 3 and 3 divided by 3, we get new numbers. 3 divided by 3 is 1. 9 divided by 3 is 3. And now we have a new problem with smaller numbers. So our new problem is 1/3 over 1/2. So again, what I did is I divided my two numbers here by the same number. I did 10 divided by 5 and 5 divided by 5. They're both in red. 9 divided by 3 and 3 divided by 3, both in blue, to get new numbers. Okay? Now, if I multiply, I'm multiplying 1 times 1 and 3 times 2. And if I multiply those two numbers together, or those two sets of numbers together, I get my answer. of 1/6. Again, you want to check to see if you can simplify your final answer. Here, since we did all of this stuff in red and blue up here, all the simplifying up here, chances are we're going to have either very little or no simplifying to do at the end of the problem. So here you can see 1/6 cannot be simplified. And that's, again, because we did most of our simplifying up here in the problem instead. Had I not done any of that, and I just did 5 times 3 to get 15, and 9 times 10 to get 90, I would have gotten 15 over 90 as my answer, and I would have had to simplify that a lot. And if I simplified it all the way down, guess what I would end up getting? 1/6. Okay, so hit pause on your video, try these 2 practice problems. After you try them for a minute, you can hit play again. I'll show you the answers and explain how I got my answers, and hopefully you got the same answers I did. Okay, here we go. So, lots of simplifying in question 1. I color-coded everything to make it easier for you to see. So what I did is I started off by simplifying the 5 and the 15. 5 and 15 can both be divided by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. Next, I simplified the other diagonal, 4 and 24. 4 can be divided by 4, and 24 can be divided by 4. And when I do that, 4 divided by 4 is 1. 24 divided by 4 is 6. You have to keep looking after you do that, though. You can still simplify it up and down right here. 3 and 6, the blue one and the red one. After I had done the blue and red, I looked, and 3 and 6 both share a common factor of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Now, my final simplified multiplication problem is 1 over 1 times 1 over 2. And 1 times 1 is 1. 1 times 2 is 2. So that's my simplified answer. Had you missed or not done some of the simplifying, you would have gotten a larger answer at the beginning when you first multiplied, but you would have had to simplify your answer, and if you simplified your answer all the way down, you should still get 1/2 if you did your math correctly. Okay? Example 2, there's only one thing I can simplify in here, and it's the 2 and the 4. One numerator and one denominator. So they can both be divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So then when I multiply, I have 3 times 1 to get 3, and 7 times 2 to get 14. Again, had you not simplified right here, you would have gotten 6 over 28 as your answer, but 6 and 28 can both be divided by 2, which would result in the same fraction that I got. Okay? Let's move on to the dividing problems now, okay? So dividing is just like multiplying, except we have to put a step at the very beginning. If you've done dividing fractions in the past, your teachers may have had a catchphrase or a rule for you to follow. What we're going to learn here is keep, change, reciprocate. So if you think back to the vocabulary words, the reciprocal was a vocabulary word, and a reciprocal is when you flipped a fraction. Okay, so to reciprocate means to flip a fraction. So we're going to take our division problem, we're going to use keep, change, and reciprocate to make it into a multiplication problem that we can use the rules that we just learned to solve. Okay, so what does that mean? I kind of just explained it, but it means that we're changing the division problem into multiplication, and then we're going to use those rules to solve. So here's why this works. We all know this problem here. 8 divided by 2 is 4. If you don't know the answer to this problem, you might need to brush up on your multiplication tables. So one other thing we know, though, is that 1/2 of 8, if you cut 8 in half, this is how you would write the math problem out for that. If you cut 8 in half, the answer is also 4. So 8 divided by 2 is 4, and 8 times 1/2 is 4. So what that means is that we can use reciprocals to convert division problems into multiplication. So 2 and 1/2 right here are actually reciprocals. I'm going to show you that in a second. And when you do a keep, change, reciprocate, so like you change this to multiplication and you change this to its reciprocal, you're going to get the same answer. Okay? So reciprocals are when the numerator and denominator switch. So here are some examples of reciprocals. 2/3 and 3/2 are reciprocals. 5/8 and 8/5 are reciprocals. 3/11 and 11/3 are reciprocals. You're flipping them upside down. I showed you some with some whole numbers here too. The reciprocal of 5 is 1 over 5, and it's because when you write a whole number as a fraction, you write the whole number over 1. 5 over 1 means 5. So when you flip that upside down or reciprocate it, you get 1/5. Okay? Same thing with this. 1/4, the reciprocal of 1/4 would be 4 over 1. Okay? Just like that. The reason that it's written like this is because most of the time when you write a whole number, you don't put a 1 below it. Okay? It makes sense because what I've been saying for the last month or so is that a fraction is a division problem. And if you do 4 divided by 1, you get 4. Okay? So those are all examples of reciprocals. So now let's identify some reciprocals. Hit pause for a minute, try to find the reciprocal of these 4 numbers, and then hit play again and see how you did. Okay, what you'll notice here is that for the first 3, questions 1, 2, and 3, I just flipped them upside down. So 7/10 turns into 10/7, 3/8 turns into 8/3, and 1/6 turns into 6/1, which I can write as 6. 9, however, remember, if you want to find the reciprocal of a whole number, the first thing you should do is start by putting the whole number over 1 and then flipping it. So 9 means 9/1. When you flip it, you get 1/9. Okay, so the reciprocal of 9 is 1/9. Now let's use those to solve some problems, okay? So the rule that we have to add before all the multiplying rules to turn the division problem into multiplying is keep, change, reciprocate. So we're going to use keep, change, reciprocate to make this multiplying. So we're going to keep the first fraction. That's what the K stands for, keep. We're going to change the division sign into a multiplication sign. That's the change. And then we're going to reciprocate the second fraction, so 3/4 turns into 4/3. So that's our new math problem. And because of what I showed you earlier with the 8 divided by 2 and the 8 times 1/2, the problem up here, the division problem, is going to give us the same answer as if we'd solve it this way. And since we know our multiplying rules, this is how we're going to solve it. So let's solve this now. Let's start by looking to see if I can simplify some things. So 5/8, 5 and 8. Cannot simplify these two. 4 and 3, cannot simplify those two. 5 and 3, cannot simplify. 8 and 4, though, share a common factor, right? 8 and 4 can both be divided by a couple things. The largest number they can be divided by is 4. So if I divide them by 4, I get 4 divided by 4 is 1. 8 divided by 4 is 2. And here's my new math problem. 5/2 times 1/3. So now let's multiply sideways. 5 times 1 is 5. 3 times 2 is 6. My final answer is 5/6. So check to see if you can simplify 5 and 6 at the end. I cannot simplify it, so that's my final answer. Okay, let's do some practice here. Use keep, change, reciprocate to solve these two problems. So hit pause and do that, and then when you're done, you can play again. I'll show you the answers, and I'll go through and explain how to do them. Okay, here are your answers. So you can see, the first thing I did, and I suggest that all students do this, write the KCR for keep, change, reciprocate above each problem. That'll help you remember what to do with each step. So here, for problem 1, I kept 5/8, I changed the division to multiplying, and I reciprocated 10/12 to make it 12/10. After I did that, I have a multiplication problem down here, and I looked for simplifying. 5 and 10 can both be divided by 5. So 10 divided by 5 is 2. 5 divided by 5 is 1. 12 and 8 can both be divided by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. And then I just multiply sideways. 1 times 3 is 3. 2 times 2 is 4. So again, if you missed some of the simplifying here, you would have gotten an answer maybe 6/8. If you didn't simplify at all, you would have gotten 60/80. If you simplified some of it, you could have gotten 15, let's say 15 over 3 times 5 is 15, so 2 times 15 over 20. You could have gotten a bunch of different things, but if you simplify at the end of the problem also, you should end up with the same answer. Everybody should get 3/4 at the end, regardless of what you simplified in here. Okay? Question 2, 9/10 divided by 3/5. Keep, change, reciprocate again, so 9/10, we're going to keep that. We're changing division to multiplying. We're reciprocating 3/5 to make it 5/3. So again, a lot of simplifying I can do in here. 10 and 5, just like in problem 1, can be simplified by dividing by 5. So 10 divided by 5 is 2. 5 divided by 5 is 1. 9 and 3 can both be divided by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. So after that, I have my simplified problem of 3 times 1 and 2 times 1. 3 times 1 is 3. 2 times 1 is 2. And 3/2 is my final answer. The only thing that we do not want you to do is leave that as an improper fraction, so make it a mixed number. So remember that you do 3 divided by 2 to make it a mixed number. Right? 2 can go into 3 one whole time, and if you do your division, you have a remainder of 1. So 3 halves, or 3 over 2, equals 1 1/2. Okay, so that was today's lesson. Remember to keep change reciprocate for dividing, and make sure that if you want to, if you feel like you're comfortable doing the simplifying in the problem like I did here, do that. Go back and watch the video at home or as you're practicing or reviewing for your quiz, and I'll see you next time.